So hello, good morning everyone. My name is Yuandong-Create from Technical University of Munich. Today I'm gonna present the thesis history about my PhD project, Built Environment Digital Twinning. First, for those who are not familiar in this topic, I'm gonna discuss some questions regarding this digital twin or built environment digital twinning. So first of all, what is a digital twin? I think the simplest definition is that it's just a digital replica of a physical built asset. And then the question is that where we can use the digital twin. In theory, it can be used in many aspects like asset condition monitoring, facility management, and maintenance, and so on. But probably you have already heard from the presentation in the last days, and the current state of generating digital twins requires much human effort. Therefore, the objective of this project is to try to automate the process of creating digital twins. I propose a pipeline to creating digital twins as shown in this graphic. So basically, we have two different kind of input sources, laser scan point cloud and images, because we believe these two different data sources can provide us complementary information. Then we consider the laser scan point cloud first. We form the room clusters. Basically, we find the largest white space inside the rooms first. And then we extract the structural elements. In this step, we use the 3D deep learning technologies to predict the labels for the points. And the interesting factor we found, like in the 3D deep learning, for those structure or large structure elements, the performance is pretty well. But for the small scale elements, for example, the light switches or smoke alarm, the performance is really, I would say, is not as good as those for the larger elements. That's why we want to add this images or videos into the pipeline to recognize or detect the small-scale elements in the 3D space. Basically, we apply the 2D image segmentation networks, for example, mask RCN, and get the semantic information in 2D images, and by a photogrammetric process, we map this semantic information into the 3D point cloud. As the 2D images already mapped into 3D space, those other information can also be used to enrich the 3D model. For example, the text information on the door sign on the board, or the text or serial numbers next to some objects, which is quite useful for the facility maintenance. Thank you so much for your attention. That's my thesis in 3.